Humanity has always desired to explore the unknown, to travel beyond the boundaries of our own planet into the vastness of space. The historic Voyager 1 spacecraft recently made contact with a highly advanced object in space, resulting in an unexpected finding. Can this revelation fundamentally alter our perspective of human life on Earth? Prepare to go on a journey of discovery that will challenge everything we thought we knew. Hello and welcome to Space Time. Subscribe to our channel and follow us. For more than a half-century, the Voyager missions have been at the forefront of space exploration, providing invaluable insight into the mysteries of our solar system. Given the amount of data acquired, it's tough to believe that these missions were not intended to go this long. The history of the Voyager program is fascinating. Michael Minovich made an important discovery when he realized that a starship might exploit a planet's gravity to slingshot deeper into space. As a result, in 1977, Voyager 1 and Voyager 2 were launched with the purpose of studying Jupiter and Saturn. What followed was nothing short of incredible. The spacecraft Voyager 1 has made contact with a highly advanced object in space. Both Voyagers contain 3.7-meter radio dishes and 16 thrusters that allow them to change their orientation and target their dishes at Earth. Their engines rely on hydrazine fuel, and their electronic components are powered by plutonium-powered thermoelectric generators. Both Voyager 1 and 2 are outfitted with 11 scientific instruments, half of which were intended for planet exploration but have already been deactivated. Consider embarking on an epic journey to explore the unknown depths of our solar system, accompanied by 2 trustworthy spacecraft. Your first mission will be to investigate Jupiter and Saturn. Isn't that amazing? And those probes delivered. They returned never-before-seen images and data, substantially altering our understanding of these gas giants and the famed ring planet. While Voyager 1 waved farewell to our solar system and sailed toward interstellar space, Voyager 2 planned some interesting stops. A correction maneuver was carried out in 1981 to guide Voyager 2 towards Uranus. After exceeding its projected estimated lifetime twice, the spacecraft eventually arrived to the solitary ice giant in January 1986. But that was only the beginning. On its way to Uranus, Voyager 2 discovered 10 previously unknown moons, contributing to the expanding cosmic family. But Neptune was the ultimate destination, where Voyager 2 took nearly 9,000 images and identified 9 previously unknown moons. The 2 spacecraft have spent the previous decade studying the vast and fascinating interstellar medium, a sparsely populated region between stars. They're still discovering new stuff. One of the most astounding discoveries is the intensity and direction of the interstellar magnetic field, which has sparked heated debate among scientists over the shape and activity of the Sun's magnetic region, the Heliopause. No other spacecraft has returned to Uranus and Neptune since Voyager 2. Scientists have been able to observe and evaluate amazing happenings on these worlds from afar. Our solar system's ice giants are few and far between, with just Uranus and Neptune among them. Despite the name, the majority of these planets' substance is not frozen, but rather comprises of hot, supercritical fluids made up of volatile chemical components like water, ammonia, and methane. It is a state of matter that combines the properties of liquid and gas. Uranus is the second most distant planet in our solar system, with an average solar distance of 1.8 billion miles and a diameter 4 times that of Earth. Uranus takes about 84 years to orbit the Sun and looks to be resting on its side during that time. The source of this peculiar axis tilt is unknown, although astronomers suspect it was created by an early collision with a massive protoplanet. This could also explain Uranus' 27 moons, which could have formed from impact debris. If that isn't enough to spark your attention, a big white spot on the surface of Uranus has been discovered. We have access to all of this information because of these iconic probes. When NASA's Voyager 2 spacecraft visited Neptune in 1989, it observed several extraordinary weather occurrences, including beautiful bands of clouds in the atmosphere and storms reaching speeds of up to 1,305 miles per hour, the fastest winds yet seen on any celestial body. Experts believe that the lack of solar energy reaching Neptune allows these storms to whip up to such incredible speeds, but they may disappear one day. During the Voyager 2 mission, scientists discovered the Great Dark Spot, a massive feature the size of Eurasia that was considered to be a hole in the planet's apparent cloud cover. However, when scientists tried to find the location again a few years later, it had vanished. The Heliopause is a vast area of space influenced by the Sun's solar wind. It is the region where the influence of the sun spreads and interacts with the interstellar medium. It has the appearance of a huge, bubble-like expanse of space. The heliosphere, formerly thought to be formed like a comet, may really be more spherical. What happens to the heliosphere when sunspots form and then disappear? The spacecraft has revealed some unexpected data. The interstellar medium begins when the solar wind, a flow of charged particles generated by the sun, comes to a halt. This ionized gas, or plasma, works like a boulder in a river, pushing up against the surrounding colder, denser plasma. The sun's hole is called the heliosphere and its edge is called the Heliopause, similar to how the top of Earth's troposphere is called the tropopause. Sunspots are dark, planet-sized patches that appear on the surface of the sun. Over an 11-year period, sunspots grow and fade, causing the solar wind to increase and decrease, pushing harder and then less on the Heliopause, albeit with a 2.5-year lag. The heliosphere grows and contracts as a result. Because the pressure from the solar wind was lower in 2012, the heliosphere should have been significantly smaller during Voyager 1's passage than it was during Voyager 2's. The nearly comparable distances, on the other hand, indicate that the heliopause is more stable than previously thought. Despite the fact that the heliosphere's exact shape is unclear, Voyager 1 and Voyager 2 continue to drift away from it. By the end of this year, Voyager 1 will be 155 astronomical units from the Sun, and signals from the spacecraft will take more than 22 hours to reach us since they move at the speed of light. When Voyager 2 passes the peaceful Pioneer 10 in late 2023, it will be 129 astronomical units away, making it the second farthest spacecraft ever. These two spacecraft are now heading in opposite directions and are farther apart than either is from Earth. Furthermore, in May of last year, the Voyager 1 onboard system known as the Attitude Articulation and Control System, or ACS, which is in charge of keeping the spacecraft's high-gain antenna pointed at Earth, began beaming home confusing jumbles of data instead of the usual reports about the spacecraft's health and status. The spaceship appeared to have suffered a sickness comparable to electronic aphasia, which impairs one's ability to communicate fluently. From our vantage point, it is possible that the data was generated at random or that it does not represent any plausible condition at all. In a statement at the time, NASA stated that the ACS could be in. Even more baffling for the engineers was the fact that, despite the odd status reports from the spacecraft, Voyager 1 appeared to be in good shape. The radio signal from the ship is still strong and continuous, indicating that the antenna is still directed at Earth and is not in the configuration specified by the ACS to NASA. Similarly, even while the ACS was experiencing anomalies, Voyager 1's science systems continued to capture and transmit data as usual. Furthermore, whatever malfunctioned with the ACS did not activate a fault prevention system, which is designed to put the spaceship in safe mode if a problem occurs. Fortunately, NASA experts were able to identify the issue and suggest a solution. The ACS had begun transmitting telemetry data via an onboard computer that had been inactive for many years. Because the dead computer corrupted all incoming data, all NASA engineers had to do was instruct the ACS to use the correct computer to relay its data home. The next step is to figure out what prompted the ACS to change systems in the first place. According to NASA, the system most likely received an incorrect command from another onboard computer. While they claim there is no immediate threat to Voyager 1's safety, the underlying cause must be identified and handled to prevent additional harm. For nearly a decade, Voyager 1 has been a true pioneer in the vast expanse of interstellar space, flying outside the protective magnetic field of our Sun. The environment is hostile, with high-energy particles and cosmic radiation bombarding the ship from every direction. Despite these challenges, Voyager 1 has continued to develop, giving critical data and insights into deep space mysteries. According to Susan Dodd, project manager for Voyager 1 and 2, strange mishaps like the latest ACS failure are par for the course in this extraordinary mission. The Voyagers are still a testament to human ingenuity after 45 years of exploration. Alright everyone, this video ends here. Thanks for watching, and remember to subscribe to our channel for more Voyager probe videos and information.